Good afternoon. Welcome to today's lesson on linear programming. Now, linear programming may seem something that you do in a computer because you hear the word programming, but you also see the word linear. So the way linear programming works will be the following. It's a way to determine an optimum value for a linear model. And what's meant by optimum is most ideal. For example, a business they want to maximize profit. Or minimize cost. Because of course, if you can lower your cost, that's a good thing. Or if you can maximize your profit, that's also a good thing. That's the kind of problems we're dealing with here. So let me provide you with a word problem, and then we will go over the steps to solving it. So I'm going to copy this. This from worksheet we'll be working on next time we see each other. So here's the problem. I'll read out loud. You plan on making chicken stir fry and chicken skewers. For every order of chicken stir fry, you need 4 ounces of chicken and 3 scoops of rice. For every order of chicken skewers, you need 6 ounces of chicken and 2 scoops of rice. Now you have some limitations here. Total 900 ounces of chicken is available, 600 scoops of rice available. The profit, $4 for every order of chicken stir fry, $3 for every order of chicken skewers. How many orders of each meal must you sell to maximize your profit? That's a lot of information. It'd be very hard to digest. So here are the steps we're going to do to solve this problem. Let me kind of space these out a little bit. So these are our steps. Step 1 will be the assigned variables. Because like any word problem, you gotta know what x and y will equal, or whatever variables you use. So you gotta assign variables for the things you're trying to find. So let's do that right now. Step 1, x will equal the number of stir-fry orders, because they're asking you how many orders of each type of meal you need to sell. So, and y will be the number of skewers orders, if you can say that with proper grammar. So again, that's where you're being asked to find how many orders of each meal must you sell. And so we assign our variables. For step 2, you want to determine the objective function. Now, I know it's not English class, but what does objective mean? The objective means goals. Like, what is your objective for today? What do you plan on accomplishing? So clearly, we want to maximize profit. That's our goal. So when I write the objective function, P stands for profit. Or if you're dealing with cost, you can use capital C for cost. We see that you can make a $4 profit for stir fry. So depending on how many stir fry orders I sell, 4x is going to be my profit from the stir fry orders. Let's say, for example, I sell 100 stir fry orders. That's $400. And the other one's going to be 3y because the profit for skewers was $3. Again, the profit for stir fry was $4. The profit for skewers is $3. Let's say I sell 50 orders of skewers. Then, of course, it's 3 times 50. So this is going to be our objective function, which we'll come back to later. We'll come back to later. And remember, we wish to maximize P, the profit. Step 3. Step 3 says here to find the constraints. Constraints, what does it mean for constrained by something? Limitations. What are you limited by? We don't have all this chicken in the order to use. We don't have all the chicken in the world to use. I'm talking too fast. You don't have all the rice in the world to use. You have a very limited amount. So you're limited by chicken and rice. Now, this is the tough part. I would say this is probably the most difficult step. If you think about it, stir fry needs 4 ounces of chicken and 3 scoops of rice. Skewers need 6 ounces of chicken and 2 scoops of rice. So let's start with the chicken. You only have 900 ounces available, right? And you can't go past that. So I'm going to write greater than or equal to. Because we're going to have to be less than 900. Or actually, let me rearrange that. That's a little confusing. Let me write like this. 900, and we got to be less than or equal to 900. Now, the stir fry, remember that's X. The skewers, remember that's Y. You need 4 ounces of chicken for stir fry, 6 ounces of chicken for skewers. So it's going to be 4x plus 6y. For example, if you had 100 orders of stir fry, that's 4 ounces of chicken. If you had 50 orders of skewers, that's 300 ounces of chicken. So you got to look at each ingredient and write a constraint for it. For the rice, that's 3 and 2. So 3x plus 2y, and it has to be under, let's see here, 600. To me, that's always the most difficult step. Oh, another thing too, you can't have negative order of stir fry or skewer. So we also know that x is greater than equal to 0 and y is greater than equal to 0. The feasible region, remember feasible represents what's possible. So we're going to graph these inequalities and shade. So you want to graph the inequalities because this will tell us what's allowed, all the constraints. As long as we stay under them or over them, whatever direction the inequality sign's at, you got to respect that. So graph inequalities and shade. This requires, some stuff that we've done recently, so it's kind of building upon what we already know. And this is going to be, a little crazy because numbers are pretty large. Now, remember, x is greater than or equal to 0, so we have to say this. X greater than or equal to 0 is that. Y greater than or equal to 0 is that. That's just the x-axis. So now we know we're shading to the right and we're shading above the x-axis, because this is like the x-axis, that's like the y-axis. So we know that the region is in the first quadrant. But of course I'm going to have some other stuff going on here. So I'm going to erase that shaded region. Now I'm going to focus on these two right here. This requires some nifty algebra. So let's look at 4x plus 6y is less than or equal to 900. 6y is less than or equal to negative 4x plus 900. Y is less than or equal to negative 2/3 x plus 150. For the other equation, or inequality actually, 2y will be less than negative 3x plus 600. So y is less than or equal to negative 3/2 x plus 300. So now we graph these. Let's say I make each of these worth 50 units. So 100, 200, 300. 100, 200, 300. If you graph this one right here, I'll use orange for that line. So if I think about this carefully, it's going to cross the x-axis at 225 when y is 0, and 150 when x is 0. So we're going to have something kind of like that. And the shading will be below. For the next one, let's use, I don't know, should have used a different color, but let's use red. Hopefully you're not colorblind. See right here, and when let me think, when y is 0, x is 200, and also when x is 0, y is 300, which we already have, you have that one right there. So the shaded region is going to be, and actually let me use have to be really careful I don't erase too much. Perfect. Let's use the highlighter. So the shaded region is right here, because you got to be beneath both lines, and you got to be x is greater than or equal to 0, which is to the right of the y-axis. Y is greater than or equal to 0, which is above the x-axis. So right now that is your feasible region. So anything in there we can use for finding maximum profit. Let me pause this video so I don't go over 15 minutes. I'm going to do a second part, and then we'll finish it up.